that gives the idea that we can report numbers which could be more precise, less precise, and that precision could be measured by a tool called significant digits. In short, we call them sig digits. Okay? So now there are rules for counting how many sig digits you really have in numbers. Okay? And these are the rules. So number one rule is that non-zero digits are always significant. Now, I'm sure some of you have seen this before in your high school classes, but so let this be the refresher, and if there is something that you don't remember, maybe this will help with that. So non-zero digits are always significant. Okay? So 22 has 2 sig digits, 22.3 has 3 sig digits. All right? Now, the situation with zeros is a little bit more involved. It's not that straightforward. So zeros could be before, could be after, could be in between. So let's look at the case when the zeros are placed before other digits that are not significant. So you have 0.046 and clearly 46, these two are sig digits, but the 0 placed before them are not significant. So this 0 before the decimal, this 0 after the decimal, but all of these zeros are before these sig digits are not significant. Okay, so this has only 2 sig digits. Zeros that are placed in between other digits are okay, they're significant. So this is going to have 4 sig digits because both the zeros are significant over here. Zeros placed after other digits but behind the decimal points are significant. So if you have zeros after a decimal point, they are significant. Now, this is important. So if you have never seen the concept of sig digits before, this may be a little bit strange to you, because 7.90 has 3 sig digits. But if you simply write 7.9, which is essentially the same number as 7.90, numerically speaking, that has only 2 sig digits. Okay? So if I say 7.90, the last digit is an estimated one, which means the actual answer is somewhere between 7.89 to 7.91, right? Because the tolerance is plus minus 0.01. But if I say the number is 7.9, then 9 is the estimated digit. That means the actual number would be 7.828, right? Because it's plus minus 0.1 then. So that changes the quality of the number completely. Even though numerically both numbers are the same, but where you place the zeros can make a lot of difference. When you say 7.90, then you're saying that I'm more precise than if I was reporting 7.9, because maybe my measuring tool was a little bit more precise, right? So this is a reflection of the measuring tool as well, or the quality of your computation, or the computational tool that you're using. So then the question is, okay, all right, so 7.90 has 3 sig digits, 7.9 is the same number, so what should we really do, okay? So the rule that we use is that you use the scientific notation, okay? You use the scientific notation. So you may have the same number, but you can use the scientific notation to get rid of this 0 problem. So if you write 8.200 into 10 to the power 3, which is same as 8.20 into 10 to the power 3, which is same as 8.2 into 10 to the power 3, numerically, they all have, the numerical they're all same, but sig digit wise, they're all different. This has 4, this has 3, this has 2 sig digits. Okay? What about these numbers? What about 820? 2 digits. So this 0, do we know if it is significant or not? We don't know. It's ambiguous. So never write numbers like this, because when you write 820, we don't know whether that last 0 is significant or not. Okay? So if you have 3 sig digits, then you should write 820 point. That's it, just a dot. Or the other option would be to write 8.20 into 10 to the power 2. Then you know that has 3 sig digits, right? 8200, again, we don't know if these 2 zeros are significant or not. We do know that 8 and 2, those 2 numbers are significant, but the last 2 zeros, we don't know. It's ambiguous. So whenever you're in a situation like this, if you use the scientific notation, you won't run into these ambiguity problems. You have a question? Okay, good. All right. So the rules are fairly simple. You just look at them, read this slide a couple of times, and you'll get it. Okay. And now I have a few examples so you can see it. All right. So now we know how to count the sig digits, right? That's great. How do you use them in calculations? Because you'll be doing a lot of calculations. You'll be given input quantities. I'll be asking for output. So when you multiply things, when you add things, when you subtract things, you use the sine, cosine formula on them. What should be your final answer reported as? How many sig digits your final answer should have? How many sig digits your intermediate calculations should have, right? That's the question. So we will divide this into 2 halves. One is where you're doing multiplication, division, using functions on the numbers, sine, cosine, logarithmic, exponential, and so on, right? When you have situations like those, you look at your expression, you look at your numbers. As long as the expression involves just multiplication and division and using the function, the input quantity that has least number of sig digits decides how many sig digits you will have in the final answer. Okay? So the final answer should have same number of sig digits as the input quantity that has the least number of sig digits. So if you have 5 input quantities that you're multiplying and dividing and taking sine and cosine off, then the one that has the least sig digits are the ones that should be used for the final answer. Okay? So example, now this is the example that we looked before. So you're trying to compute the force on an object of mass 2.5 kilogram, acceleration is 1.236. Those are the 2 input quantities that you're multiplying. This has 2 sig digits, this has 4. Your final answer should be reported in 2 sig digits, right? So if you compute this, you put the numbers in calculator, you get answer as 3.09, which has 3 sig digits. So you need to round it to 2. And if you round 3.09, you basically get 3.1. So the question is now, how do we do rounding, right? That's coming. So the question of rounding will be answered pretty soon. But this has 2 sig digits. If you're doing addition and subtraction, the rule is slightly different. You don't count sig digits. You look at the input quantities, and you look at the input quantity that has least number of digits after the decimal, and you report those many digits after the decimal in your final answer. That's the rule for addition and subtraction. Okay, so it's not decided by the number of sig digits. Sometimes sig digits may be same as the, you know, if you use the sig digit rule, the answer may come out to be same, but the real rule is that you just look at the decimal places after the decimal for addition and subtraction. Okay, so if you want to add these 3 numbers, you know, these are these are numbers which are for energy, let's say, because you have joule over here. So you have 2 digits after decimal here, 1 and 4 over here. So your final answer should have only 1 digit after the decimal. So you plug in these numbers, you add them in your calculator, and you may get a number which has maybe 3 or 4 digits after the decimal. You have to round it so that you have only 1 digit after the decimal. Okay. Now the question is, what do you do with your intermediate calculation? So you may have, you know, maybe 10 things that you have to compute before you report your final answer. General rule is that for your intermediate calculation, you try to retain as many digits as you can. Okay. So if you're doing all the calculation in your calculator, then you don't need to worry about it, right? Because your calculator is storing a large number of digits after decimal, or has very large number of sig digits. It's only when you report your final answer, you look at your input quantities, and you report the right number of sig digits based on the rules we discussed. Okay? If you're writing intermediate calculations on a piece of paper, maybe this is exam or homework, and you want to show what your intermediate answers are, you report up to 4 digits after decimal. Okay? 4 digits after decimal. So that means you'll at least have 4 significant digits, right? And then your final answer should follow the rules that we just talked about.